Okay, for the benefit of all, one last time. The ls uh, I is assigned to with 0, while I is less than n and a of I is not equal to the key value I plus plus, of course, in this is inside orientation wise, and the next line is in the same orientation as these two loops, the loop and the assignment. So the if else is outside in the same orientation as both of them. If the idea is that, of course, if we are getting out of the loop, this condition must be false. If it is false, then either of the two must be false. So we are saying that suppose this is false, that means we have found the key, but this has to be false while we are in the array, so this has to be true. So if we say if I is strictly less than n, so this is true, that's what we are saying, and we know the whole condition is false because of this only, so that means we have found ai equals k, so we just return I maybe, else. Of course, this is not false, that means that we have already searched in all of the array and we have not found the key. That is what the interpretation is. And so basically, if this is false, that means I is greater than or equal to n. That means that this is false and this is false. So now this is true or false doesn't even matter. Why? Because we needed to find k within the range, and if we are already beyond the range, of course, till this point the whole condition was false because this was anyways true one. So of course when basically this was always true while the loop was going on, and suppose if the key is there, this will be false only because of this, and then we make sure that we are inside the loop, and if that is not the case, so we just return -1, and that's probably it. Binary search is probably better in that you initialize L as 0 and R as n-1, and then you use iteration method because it is better from equal to R. Then you give mid as L plus R minus L by 2 integer division, or basically this the floor function of that, and then you say that if a mid is equal to key value, then just of course return m property. If that is not the case, then we use another if. Of course, this isn't true. That's something that we know. We can also use if else construct, if else if and all. Of course, when this is false, then the next line will be executed. Otherwise, it will just return M. So, but we can also just use if. That doesn't matter because they are all primitive operations of the same big O of 1. And the idea is if AM is greater than, it cannot be equal, of course. Then in order to find the K, it has to be in the left, because that's what this inequality tells us. So I'm not using braces because they are just one liners that code after the if else. So basically we need to shift R to M minus 1, else we know this has to be false true. So now, of course, else means AM is less than or equal to K. But we know that this if else is being executed when this is false. So it cannot be equal to K. So there's no problem basically. We can also use else if to write the condition maybe. But here there's no problem. And L is basically M plus 1. The heck. Okay. And if this is the inside indentation on this code, and then return -1. There might be cases in which we have to store some variable in ANS or something, return ANS by initializing it here. Of course, there's a functional prototype in which we give LR, the array pointer, and probably the mid also. No, mid we declare locally inside the function scope. So LR, the M, then the function pointer, the probably 4 prototype in DS. Yeah, and that's it.